Hi guys.
Hi, morning.
Morning.
Morning. Morning, it's already noon. Okay, how are you?
Good.
Fine.
I see all of you.
Just so.
So. Okay. Okay. So you are only four persons anyway.
Where did you find it?
Maybe some other guys will join later on. Shall we start? Are you ready?
Yeah.
Okay, great. Did you have any online courses already before this?
Yes.
Okay, good. Okay, let's see. So in the Neptune system, I already shared you some information. So I'm planning to give my lectures in Zoom. We will see how it will work. You should know that in Zoom, there is a 40-minute time limit. So after 40 minutes, probably this meeting will be interrupted. We are already 5. So the meeting will be interrupted, but I will restart the meeting immediately, and I hope there will be no problem. You won't notice anything. Okay, let's hope so. If after 40 minutes I cannot rejoin to the meeting, then I will send you some Neptune message about the new link to the new meeting. Is it clear?
Yes.
Yes.
Okay, but let's hope everything will be fine. Okay, so first of all, how should we start? I have a Kahoot quiz for you, and I also have some learning materials to share with you. What would you like to do first?
Kahoot.
Kahoot, okay. And just a minute. Yeah, okay. So let me try to share my screen with you. It plays music. Wow. I didn't know Kahoot plays some music. Yeah, it's much better. I hope there is not too long delay in Zoom. Okay, can you see the entire screen? Hello?
Yeah.
Sure.
Okay. We are 6 already. 6 persons.
People.
Okay, then let me start. Ready? Go. Nice. Yes, in C++ there is multiple inheritance, but not in C# or in Java. Good. Which statement is false? You should select the false statement now. You have plenty of time. Nice. Yeah, this is the correct answer. So a private field cannot be redefined in a child class because from the child class you cannot access a private field, right? So you can redefine only a protected or public field, nothing else. Okay, next question. Oh.
As usual.
Which statement is false again? You should select the false statement.
Oh my God.
Okay, now it's 50-50. For late binding, you have to use both the virtual and override keywords. You know, those two keywords, virtual and override, should be used together. For early binding, you can use the new keyword. Here you can see a piece of code now. Let me try to zoom in. You have 1 minute. You should find out what the main method writes to the console. You can see the main method with background.
What?
You have plenty of time.
Override. Okay. Actually, it's
Yeah, nice. Exactly.
Didn't attach it.
Okay, then last question, I think, is coming. Ready?
Ready.
Which statement is false again? Again, you have plenty of time. Oh. Well. Okay. Okay, let's see. Do you any guess why this is the correct answer? Can you hear me?
Yes.
Probably I cannot hear you. Okay, first of all, so now we are talking about a virtual property, you know, a property with a get or a set, and you want to override such a property. So the question, where should you write the override keyword? And you should always put the override keyword in the header of the property. Let me show, yeah, I will show you a slide later on. What is completely wrong is the blue answer. So if there is a missing get or set in the parent class, you cannot even override it. You can override something which already exists in the parent class. You see? Okay, let's see the final result. It's shitty music. Okay. Congratulations. So who was the first one? Ah, Shiji. Congratulations. Well done. Yeah, let me show you this slide I was talking about before I ask you if you have any questions. So last time,
like he was asking the false. Yeah, he was asking the false.
So last time I was.
Hello, sir. Can you hear me, sir?
Excuse me?
Ah, okay.
I can hear you, yes. I cannot. Maminka is muted, so I cannot hear him. Now he's not. Okay. But you can mute yourself if you don't want to say anything.
Because it's noise at here, so I sometimes I need to mute.
Yeah, exactly. Okay, no problem. You can mute yourself if you want, if the background is very noisy. Okay, so I want to show you, where is it? Yeah, this one. So here, it is about how to inherit properties, and you can use the virtual override keywords. And as you can see in the example, so you have to put the override keyword in the header of the property, you see? Not in front of. What?
You know, like for the last questions, it was which statement which is false.
Yes.
So then here you say like we should write the keyword override in front. And that's true.
You are right. Yes.
And you know, I clicked that blue. The blue was true, but it showed that I'm correct. I'm not correct.
Yeah, I think you are right. Yeah.
I think it's even there is another question in the beginning, like two of them.
Let me just see what, if I set it wrong, set it in the wrong way, but probably, yeah, surely I did. Yes, you are right. Oh, okay.
I guess that there is another question, I guess, in the beginning.
Yes. Okay, then, yeah. Then five of you were right. Even the blue answer and the right answers are incorrect, are false. Then I will count this in the result. Okay, sorry for that. Thanks for noticing this. You are right. Okay, then my apologies. Okay, so anyway, on the slide you can see the correct way of using the override keyword, and this is what you already know, it seems so. Okay, is there any other question or comment regarding the Kahoot quiz? No, okay.
No, yeah.
Okay, then let's talk about the lectures. Okay, so I'm planning to give the lecture every week because
Because of coronavirus.
Excuse me?
He said because of coronavirus.
Yes. Yeah, I don't give all my lectures actually. For some lectures, I only talk about 20 minutes, then I let the students learn by themselves. But here with the high-level programming languages too, the problem is that there is no up-to-date, there are no up-to-date lecture notes. So the lecture notes you can access on the e-learning site are quite old, not up-to-date. Therefore, I need to share with you the new, the up-to-date material. So this is the reason. I hope you don't mind. So every week I will show you my slides and I will talk about them. So every week on the e-learning site, you will find such a paragraph here with the link to the Zoom meeting and also some slideshows. Now today we need to learn 2 slideshows, and this is what I'm going to comment now, and that's it. So this is how we will proceed. Okay, understood.
Yes, sir.
Yeah.
Excuse me, is there any question?
No.
Okay, it seems someone is talking. Okay, and I will try to make some new Kahoot quizzes, not every week, but in every 2 weeks, let's so to say, something like that. Okay, then, so today we are, as I mentioned, we are going to learn about 2 topics. The first topic is called constructor chaining. The other topic is called type compatibility. So both topics are topics which you should know also in the exercise class. Did you already have your exercise class with Gábor Kusper?
Last week was cancelled.
Mm.
This
this week, do you know anything? Not yet. When is it?
Thursday.
Thursday. Okay. So if everything works out, you will learn about these 2 topics in the exercise class as well. Therefore, today I'm going to hurry a bit and talk about those 2 topics. Okay, so let's see the first one. The first one, where is it? Okay, can you see the slides?
Yes, sir.
Yeah.
Okay, meanwhile, whenever you have a question, just ask the question and I will try to answer. Okay, so constructor chaining, what is this about? So actually, this is something what you already know. I mean, the basics you already know. It is about constructors calling other constructors. And you already know that you can use this keyword to call another constructor from a constructor. Here is an example. So this is, you already know. Am I right?
Yes.
Okay. But now we are going to learn about the next layer of constructor chaining, because with this keyword, you can only call a constructor inside your class. Now we are going to learn about how you can call a constructor in the parent class. Frankly to say, whenever there is an automation in C#, so whenever you call a constructor, just look at the blue box on the right bottom in the right bottom corner. So there I'm calling the constructor of O3. So whenever I call a constructor, automatically, this is very important, automatically the constructor in the parent class is executed. So the constructor of O2 is executed as well automatically. This is interesting. And if the O2 constructor is executed, then the constructor in O1 should be executed as well.
Yes.
So this means that all the constructors up to the object class are executed and automatically. So this is done automatically by the system. This is kind of interesting. Okay, I will show you a proof soon. But I would like to mention that these constructors, as the figure shows, are executed from up to down. So first the object constructor is executed, then O1, then O2, then O3. Let me show you this example. So here I have a square class. It has a child class rectangle, which has a child class trapezium. And in the blue box, I'm calling the trapezium constructor. So this means the constructor of rectangle and the constructor of square are also executed. So what do you think? What we are going to see on the console? What do you think? In what order those constructors will be executed?
From the bottom.
Excuse me?
Like third line, then second line, then one line.
Linear, is it?
Yeah, so first the squares constructor is executed, then the rectangles one, and then the trapezium or trapezoids constructor anyway. So you can just, if you want to try this, just copy and paste this piece of code, execute in Visual Studio, and you will see the proof that I'm not talking bullshit. This really happens, this automation in the system. Do you get it? I cannot hear anything. Nobody responded, I guess.
Yeah.
Okay, then let me continue. So, so as I already told you, this is an automation in the framework. Not only in case of C#, this automation happens in almost all the object-oriented programming environments automatically. So this is why you should know about this. but there are some problems. So by default, the constructor with no parameters is executed, as you can see in the previous example. So none of the constructors has any parameters, and the automation worked. So what if a class has no such constructor? What if constructors have parameters? And what if a class have several constructors, right? How to pick one of them? And most importantly, how to pass parameters, actual parameters to constructors. So I don't want to steal your time. Here is a solution. This one, you should know about this one. You can use the base keyword instead of the this keyword, you see?
We did already this one.
You already did this?
Yes.
With Gábor Kusper?
Yes.
Okay, so you know about this, great. Okay, so you already used this. Just remember what I just told you. So this has some connection with this automation about constructor chaining, and this is how you can intervene. This is how you can pick a constructor from the parent class and call that constructor with actual parameters. That's it. Okay, so just read please the slide and tell me that you know all of this.
Yes.
Do you?
Yes.
Okay. Okay, anyway, let me show you another example here. As you can see, you can also use the this and base keywords next to each other. But I suppose you already tried this with Gábor Kusper. Okay, nice. But I guess you didn't learn about how this works in other programming languages. Therefore, I'm going to talk about this. As you can see in C++, so I already mentioned you that in almost all the OP languages, the same stuff happens, this automation of constructor chaining, but the syntax could be a little bit different. In C++, for example, there is no this or base keyword you can use in the header of the constructor. You have to name the class, name the constructor you want to call. That's it. Actually, I really like this way of calling constructors. You have to name the constructor. But the idea is the same. In Java, the resemblance with C# is even stronger. You can use the this keyword. I'm running out of time. I can use the this keyword, and instead of the base keyword, I can use the super keyword now. And but not in the header of the constructor, rather in the body of the constructor. Can you see that? I hope so.
Yeah, we can see that.
So it's quite the same. Quite the same. The syntax is a little bit different. Now, I know that you want to know how this works in Python.
Yes,
So let's see what is going on in Python. it's interesting. In Python, there is no constructor chaining. I mean, not automated constructor chaining. This shows that Python is not a real OP language. Anyway, we already learned before that in a class, you can have only one constructor. You cannot overload constructors in classes. This is one thing. The other thing is that, just look at the example. Now I have a person parent class and a student child class. And in the student child class, from the constructor, I would like to call the constructor in the parent class. So this doesn't happen automatically in Python. I have to force to call the constructor, and this is how you can do this in this very ugly syntax. So you should remember this if you program in Python, there is no constructor chaining, not automated constructor chaining. You should chain your constructors if you want. Okay. Is there any question regarding constructor chaining?
No.
No.
Okay. Then let me talk about a constructor which you are not going to learn about with Gábor Kusper. And this is a class level constructor. Do you remember what class level means? How can you make something class level?
When it's private.
No. Which keyword you should use to turn something class
Static.
level? Yes, static, exactly. Thanks. Yeah, so the question is there any, just a minute, my cat wants to enter the room.
Robo.
Speaking to Robo.
You want to see my cat?
Yes.
Nice.
But Robo, you will eat it.
Actually, I have two cats. This is one of them. Okay, so where was I? Static constructor. So
Static.
the question is if it makes sense to use a static constructor, and it does. So we learned that in a class you can use static fields, static properties, static methods. If you want to initialize your static fields, then you might need a static constructor, because a constructor serves this role. It initializes fields. Anyway, the point is that yes, you can use a static constructor, and sometimes you need it. Since this is a constructor, the name of the constructor is fixed. You know, it must be the same as the class name. There is no return type. That's it. So in this sense, this is a normal constructor, but it must be static. It cannot have any parameter. This is a very strong limitation. Static constructor cannot have any parameter, and it must be private. It is so private that you cannot even set the accessibility of this constructor. You cannot even set it private or protected or public. It is by default private. Yeah, so let me show you an example. Here you can see a student class with two static fields. The first field stores the number of students you have in the system. You can initialize it easily to 0. So sometimes you don't need a static constructor to initialize a field. You can just put the initial value there. But in the case of the second field, how to say, the max number of students, you need a more complicated way of finding out what the initial value should be. So in this case, I would like to ask the user what the max number of students should be at the beginning, and the user types it in. I hope you understand. So in the case of max number of students, I need a more complicated piece of code to initialize the field. So this is for what we can use a static constructor. It is static, it is private, so you can't even put the private keyword in front. The name is student, it has no parameters, that's it. But otherwise it looks as a constructor. So the point is that, maybe I have another, oh no. Yeah, so the point is that in the static constructor, you can use, how to say, you can use very complicated code if you want. For example, in this case, you could also read the max number of students from a database, or you could just generate a random number. So if you need a complicated code to initialize a field, a static field, then you should use a static constructor. That's the point. Do you get it?
Yeah.
If you don't get anything, just raise your questions. This is why I chose to use Zoom for this meeting, to make it as interactive as possible. So, okay. Okay, about the static constructor, very important question. How can you execute? How can you call such a constructor? Let me answer this question. You cannot call this constructor because it's private, right? So you cannot call it from outside. Nobody can call a static constructor. So the question is, what happens then with this constructor? So the answer here is that the framework automatically executes such constructors. When? This is the next question. The point is that we cannot know when the framework will execute our static constructors. It will just happen. But we know that it should happen before our class is used for the first time. So before my student class is used, a static constructor will be executed automatically by the system by using some magic or something like that. Therefore, I can be sure that the max number of students will be initialized before I start to use my student class. The framework ensures this for me. In other languages, so let's see, it's interesting. In C++ and in Python, you cannot use any class level constructors. There is no such thing in those languages. you can do some work around in those languages, but these are typically ugly approaches and some rough emulation of class level constructors. Anyway, in C++ and in Python, there are no class level constructors. Java is different. In Java, you can use static constructors. Actually, they are called static initializers, not constructors. If you look at the example here, you can see that in Java, you don't have to put the constructor name there, just the static keyword, and you can immediately start a block of instructions, and that's it. This is what we call a static initializer, sorry. But actually the idea is the same. So if we compare the code in C# and in Java, they look quite the same. Actually, I prefer the Java code. It doesn't make too much sense to write the class name there and the parentheses, since there are no parameters, right? Anyway, this is how the Java code looks like. You should know that. Who knows, maybe later you will program in Java. Okay. If there is no question, then I would like to continue with this. I have only a few slides left from this slideshow. I think this is the last topic in the slideshow. Object Factory. So Object Factory is one of the, how to say, object-oriented patterns. Yeah, someone was talking. Parkash, maybe you.
Yeah, it's no.
I thought Parkash said something. You didn't?
No, I didn't.
How should I call you, Om or Parkash? How? Om. Oh, okay.
Both like.
Okay, back to the slide. So in object-oriented programming, there are very good patterns what you can follow if you want to program in a nice way. Later on, after you completed this course, you will have another course about those patterns. They are called design patterns. So you will learn about a lot of such patterns, object-oriented patterns in a course later on. But now I would like to mention one of those patterns. It is called Object Factory because it has something to do with constructors, and it's a nice pattern you can use in your programs. So let me first raise a question. So what do you think? What happens if my class has only private constructors, no public constructors, no protected constructors, only private constructors? What happens then? What do you think? Is there anything I cannot do with my class?
You can't call.
We can call it. We can call the constructor. And if we cannot call a constructor, then I cannot. Yeah. Sabri?
Create like a protected or public method.
Excuse me?
Protected or public methods.
Yeah, I need public or protected methods. This is what you mean?
Yeah.
Exactly. So both of you were right. I cannot call the constructor because it's private. I cannot call it from outside. So I cannot instantiate my class. Therefore, if I want to instantiate my class, I need a protected or public method to call the constructor, the private constructor, in a indirect way.
Yes.
So we learned, yeah, that's it. You learned about this solution. You use private fields in your classes or protected fields, and typically you create public properties or methods to, you know, to access those private stuff, that's private stuff indirectly. Okay, the point is that if my constructor is public, so if my constructor is public, anyone can call it anytime. So I don't have any control who calls my constructor and what he or she does with my constructor. Therefore, if I want to control the instantiation of my class, I have to hide my constructor, make it private, and use a public method or protected method to instantiate in a controlled way. So, and this is what we call an object factory. It's a factory about creating objects in a nice and controlled way. So let's see an example here. Well, it's kind of a dummy example, but anyway. Yeah, here in my class, I use a counter. I count how many instances I already created. Then I have a private constructor. I didn't write anything in the body of the constructor anyway, but then I'm using a public method, a public static method, to be more precise, which can check some conditions. For example, in this case, I don't want to.
Are you going to the market?
Are you going to the market?
My roommate.
Be careful. There are people in the market.
Yeah.
Try to keep distance from them.
So, sure.
Okay, Rasul just wrote me a message that he doesn't have any audio. I don't know why. But he says he and Shiji is in the same room, so they should have audio together. Okay, anyway.
We use
Excuse me?
public static my class. My class is the class name, right?
The class name is my class.
So, but we use it like as a type.
Yes.
Oh, okay.
You mean the return type?
Yes.
Yes, exactly. So this create method can create my class instances. If the instantiation works out, then it will return such an instance. Therefore, the return type of the create method is my class.
Mm-hmm.
It's kind of interesting. This is what you were talking about? Yes.
Exactly.
Good. It's good that you noticed it. Exactly. So the create method checks some conditions if we can instantiate right now. And if we can, we create a new instance by calling the constructor and returning the new instance. As you can see in the blue box, we can notice that the instantiation didn't happen by checking if the return value is null. So if we cannot instantiate inside the create method, we return the null value. So this is it. Let's see another example. I think this example makes more sense. So now we have a user class. I created a private constructor which receives a name and a password and sets them. Just imagine what happens if the constructor is public. Then anybody could call this constructor with any password, with very weak passwords, for example. There is no control. I would like to check if my password is strong enough. So therefore I hide the constructor, I make it private, and I create a public static method, create user, which checks if the password is okay, is it strong enough? And if it is, then I call the constructor and return the instance. Otherwise, I return null. If you check out the blue box, you can see that I would like to set the password 123, which doesn't seem very strong, right?
Yes.
So in this case, probably I will receive a null value from the create user method. So that's it. Do you get it? Do you get this?
Yes.
Okay. Yeah, so this is what I wanted to share with you, this design pattern. But as I told you, you will learn lots of other design patterns later on in other courses. I think Gabor Kusper or Mr. Taiti has such a course in the next semester or something like that. I hope you will enjoy it. Well, you have to pass this course first successfully, and then you can enroll to that course.
Yes, sir.
Okay, no questions so far?
No, sir.
Thanks for the questions so far. Okay, this is the end of my slideshow. Oh geez, so many time already passed. Are you ready for the next slideshow? Because I have another one.
Yes, sir.
Yeah, let's do it. Let's do it because after these two slideshows, I have much more difficult slideshows to use. So next time I would like to show only one slideshow, not two. Anyway, oh, well, just a minute. Okay. So here it is. It's interesting. The 40-minute time limit didn't happen. So we were not interrupted by Zoom. Nice. Okay, next slideshow. Title is type compatibility, which sounds a little bit boring, I guess. But I hope you won't be bored too much. Actually, you know something about this topic already. You know that some types are compatible with other types. For example, you know that the int type is compatible with the type double. Just imagine this situation here. You use a method calculate with a double parameter. You can easily call this method with an int actual parameter, right? This is something you can do because the int type is compatible with the double type. So we call a type compatible with another type if this type can appear anywhere where the other type appears. So int is compatible with double. What do you think? Double is compatible with int? No, exactly. So compatibility typically doesn't work in the other way around. It's a one-way relation. The point is now we have to talk about type compatibility between classes. So it's very easy. We consider a class compatible with another class if the first class is the child class of the second class. Why this is true? Because the child class inherits everything from the parent class, every fields, properties, every methods. Therefore, you can do anything with the child class what you can do with the parent class. Therefore, the child class is compatible with the parent class, right? Yeah, so that's it. Child classes are compatible with their parent classes. So it's really easy to understand. And of course, this compatibility is a one-way relation again. It doesn't work in the other way around. Okay.
Yeah.
Okay, let's see an example. So here I'm using a method display with a square parameter, and inside the method I call something, doesn't matter. Look at the main procedure. There I create a square instance and also a rectangle instance, and I can call the same method, the same display method, with even a rectangle parameter, because rectangle is compatible with square, because the rectangle class is the child class of square. That's it. Another example here. Let's suppose I have a mammal class which has two child classes, dog and cat. And in the blue box you can see now I creating a list of mammal instances. So in this list you can have dogs and cats and other mammals mixed. And then I'm using a for each loop to traverse in the list. So I iterate through all the mammal instances, which can have either dogs or cats or other mammals. And I can call the bare child method. Why? Because the bare child method it was already created in the parent class. So all the child classes have the same method. So they are compatible with the mammal class. Just look at the example a little bit more. I'm coming back in a few seconds.
Father name.
Paranoid, basically. Who's in your room? Bro, he's walking. What? It's closed.
Get out of here.
Get
out of here.
Tell him, bro. Be careful, bro. It's class. You are walking in the class.
Sorry? Chill, get out of here.
Chill. Okay, let's play PUBG. No, 4.
So what's up? Any question regarding the example? No. So I just want to emphasize again that cats and dogs are compatible with mammal because all of them have the same stuff.
Yes.
For example, you couldn't call inside the for each loop, you couldn't call the bark method, right? the bark method, because the bark method was introduced in the dog class. So not the cats cannot bark. So the cat class doesn't have a bark method, and the same way the mammal class doesn't have a bark method. Okay, let's continue. Okay, do you know this property, transitivity? Have you ever heard about it? You should have in courses on mathematics. Anyway, I can explain it very quickly. Just look at the example. So you have a parent class X, which has a child class Y, which has a child class Z. So of course, Z is compatible with Y, Y compatible with X. This means that actually Z is compatible with X.
It's like mathematics.
Yeah. Can you tell me another class with which Z is compatible? Z is compatible with Y, Z is compatible with X, and there is another class which Z is compatible with. Any idea? Then let me ask a question. Does X have any parent class? X.
No.
Yes.
Yes.
What is the parent class of X?
Y and Z?
No. The parent class.
Object.
Yes. Object.
Yes. Object class, bro.
What is going on in the background? By the way, do you now live in the apartment houses?
Yes.
Yes.
Good for you. Do you like it?
Yeah, it's good.
I guess so. I've heard that they are kind of nice. The view is nice.
Yeah.
Okay. Yeah, so back to the question. Yes, we learned that a class like X is inherited from the object class. So always the object class is on the top. So everything is compatible with the object. This is not that important. Yeah, and this is not that important either. This is just the extended example of the previous one. Yeah, let's talk about the object class. Thanks for mentioning this. So every class is compatible with the object class. And actually, this is something you already experienced. As far as I remember, you already did this with Gábor Kuspel. You overridden the toString and the equals methods inside your classes. Do you remember this?
No, we did it to string.
You did this with only the toString method. Yeah. Okay. Yeah, you can. So I mentioned last time that the object class has three virtual methods. ToString is one of them, and there is another one equals, and there is a third one.
Get hash code.
Yeah, that's it. I feel so proud. Okay, equals. Let's talk about the equals method because this is in this example. Equals method has one parameter of type object. Because the reason of this, because you, how to say, you can use this method with any parameter of any type. You can call it with a square parameter, as you can see in the main method, but you could do the same with a rectangle parameter or trapezium parameter or dog or cat. So this equals method should be able to receive parameters of any type. This is why the parameter for the object method is, for the equals method is of type object. Yeah. Okay, anyway, if you try to, what happens here? So I want to check if two squares are equal. What does it mean? They have the same side length. Side length is stored in the field A. So I check if the A equals inside this instance equals to A in this other instance passed as a parameter. If you try this, you get an error message here. So the question is, what is wrong with this line? Let's analyze this. So here, first I check the A field of this. This is of type square, so this dot A makes sense. There is no error in that. So the error should be in this other expression O dot A. Here the problem is that the type of O is object, and object does not have an A field. Square does, but object doesn't. Therefore, you see, so therefore here you get an error message, a type error, type exception. So how to overcome this problem? So this is, I guess this is something new, but you will tell me if you already knew this. There is a special operator as, which you can use for converting or casting your instance to a specific class. Just look at the example here. You cast O to square and you get a square instance back, N, and now you can legally access the A field of N because it is of type square. Can you see that?
Yes.
So this is what you have to do to typecast your instances to specific classes. Have you ever used this as keyword before? No one? Okay, anyway, you will need this. You will need this in the exercise class as well soon, I guess. You will use it. Okay. Okay, this is not that important. You can do this. You can do this casting and accessing the A field in one line if you want. This is also possible. Yeah, actually, about typecasting, you already learned another way of casting. Do you remember this? So you can cast something to a type if you put the type in front between parentheses. So actually both ways of cast works. This is the new way using the as keyword, and you can use also the old way. there is only one difference. The S keyword returns null if the cast cannot be done because types are not compatible. The old way of cast throws an exception. So this is the only difference here. I just want to mention here that they introduced the S keyword because it's easier to read. That's it. That's all. It's nice. Okay, let's continue. So, how much time do I have? Yeah, okay. There is still some time. Okay. Yeah. So about casting, if the type of your instance is not compatible with the class, then the cast cannot be done. So there should be some way for you to check if the cast can be done. For this, you have to learn this other keyword, other operator is. It's easy to use. It returns true or false. Yeah, I don't want to over-explain it.
Value.
It's easy to understand, I guess. So you can check if an instance X is compatible with square or rectangle or anything else. For example, look at the example. So we have a display method which receives a square parameter, and then I check if X is compatible with square. Then I don't know, I display I display the perimeter of the square. Otherwise, if X is a rectangle, I calculate the perimeter in a different way. So you can do case distinction. But I intentionally put here a very bad example. So could you tell me why this is a bad example? It's not really, it doesn't really work. Do you know why? I mean, it works in a very bad way. Do you have any guess what is very strange about this method?
Rectangle also not compatible.
Sorry, could you speak more loudly?
If both is not compatible, also rectangle.
Yeah, so there is no else at the end, right?
Yes.
This cannot be happen in this case. So there is no. So this won't be a problem. There is another problem. No guesses. Okay, let me just tell you what is very bad here. So the display method receives a parameter of type square. Then I check if X is compatible with square. It's naturally is, right?
Oh.
So this condition in the if instruction is always true.
Mm.
So this is always true, therefore the else branch won't be executed anytime. Therefore, this is how this should be done. First, we should check if X is compatible with one of the child classes, right? We should check the child classes first. And only after them, we should check if X is compatible with the parent class. Actually, if you write an else instruction at the end, it relates to the parent class. Do you understand that, more or less?
Yes.
Yes.
Okay, let's see the last line here. Always unnecessary to check if X is compatible with object. Why is this unnecessary? If an instance is compatible with object?
Because we know actually,
It's on the top.
What do we know?
we know that X is on the top, like so his parent is object.
Yeah, exactly. So whatever type X has, it must be compatible with object because object is the parent class of everything, right?
Yes, sir.
So checking if an instance is compatible with object always returns true. This is always true. X is object. This is always true. It has no sense to check it. And similarly, casting something to object, X as object, this is also unnecessarily, sorry, this is also unnecessarily.
Unnecessary.
Yeah.
Necessary.
Okay, thanks. Here is an exercise for you. So, okay, focus on the exercise. I have two classes, a person class with an age field and the child class, skinny person, with a weight field. Inside the set method, I'm trying to set, first of all, the set method receives a parameter X of type person. And this is what I'm trying to do first, to check the age to 11. So what do you think? X.age equals to 11 is correct, or it might throw an error? What?
Correct.
Correct. Exactly. The first line, X.age equals to 11 is correct. Why? Because person already have an age field. What about the next line? X.weight equals to something?
It's correct.
No. It's not correct. It's incorrect. Why?
Right.
Because?
Yes.
It does not wait.
Exactly. So the type of X is person, and the person class does not have a weight field. Actually, the C# compiler is really stupid. It looks at the type of X and then it checks if this type has a weight field. So this is not correct. This would throw a compilation error for you. So it makes some sense to check if X is compatible with skinny person, right? So this is what you can see in the next line. We check if he's actually a skinny person, and if it is, then I'm trying to set his or her weight. So what do you think about this line? Is it correct, or we get an error message? Thanks. No, it's not correct. Because, thanks, yeah. Because, as I told you, the compiler is stupid. It's really stupid. It checks the type of X, which is person, and the person doesn't have a weight field. So this part, X.weight, throws the compilation error. Because the compiler cannot analyze this code. It cannot analyze that we only try to set the weight field if the condition here was true. So this doesn't work either. Just try it later on in Visual Studio. The next line is already okay. So if you cast your X to skinny person, then you can access the weight field already. You see? But what happens if inside X you don't have a skinny person instance, or your person instance? Then, as I already told you, if on this slide, so if the cast cannot be done, null is returned. If for whatever reason here X cannot be converted to skinny person, this returns null, and then we get an exception. So this line, how to say, you can compile this line, but when you execute your program could throw an exception. So the point is, you should use the last solution always. Okay, guys, always use the is condition first and only then the as operator inside the if instruction. This is the safe way of casting your instances. This was the real message here. So even in the exercise class, always use the is and as operators together. This is the safe solution. Do you get this?
Yeah.
Okay, I almost finished. What's the time, by the way? Oh, okay. Okay. So let me talk about the object class a little bit more. As I already mentioned, you already use the object class lots of time, and also the time compatibility which comes with the object class. I think you know that the console write line method receives object parameters. Therefore, you are able to pass integers, doubles, strings, skinny persons, dogs to this console.writeLine method because all of them are compatible with object. A very similar effect happens with lots of classes. For example, in the namespace system.collections, you can find classes like array, list, and stack. Do you know what a stack is?
Yes.
Okay.
So how does this work? This data structure, how does this work?
Does work on the top. Like we can add or remove from the top.
Yes, that's it. So this is a data structure. You can push new elements which on the top of each other, right?
Yeah.
And then you can remove the very last element from the top.
Yeah.
Yeah, this is what we call pop. You can
Pop,
push
yeah,
elements
push and
and popping the topmost elements. So in this namespace, you can use the stack class if you need such a data structure. And in this stack, you can store any kind of elements. You can push an integer first, then a double, then a skinny person. And therefore, the parameter for the push method is an object, and the pop method returns an object because it must work with any types, right? So let's see an example here. Let's suppose I'm creating a new stack, and then I'm creating an instance of my class, and then I push it. And this works, right? Since the type of X is my class, which is compatible with object, you see? Push receives an object parameter. My class is compatible with object. So this works. So what happens if I pop something from the stack? This doesn't work. Do you have any idea why not? Do you remember what object, what result the pop method returns? It returns an object, right?
Mm-hmm.
So I have an object which I would like to store in a my class variable. But this is the problem. Object is not compatible with my class. My class is compatible with object, but not in the other way around, right? Therefore, I really need to cast this object to my class, but this is not safe. Therefore, we should use, you know, the is and as operators together. First, we check if we can cast, and if we can, then we do.
Yes.
Okay. Last two slides very quickly. In other languages, in Java and Python, it's interesting. There is some substitute to the is operator. They are called differently. In Java, the is operator is called instance of. In Python, on the other hand, in Python, you have to use a function, is instance function, instead of the is operator. But actually, the idea is the same. If you look at the source codes, you can easily get used to them, right? What is even more interesting, not even in Java nor in Python, you can use and the as operator. You can only use the normal cast. If you look at the Java source code here inside the if instruction, you see that I cast X to skinny person with this parenthesis. In Java, you can use only the normal cast. In Python, there is no cast at all. You cannot cast instances to types because Python is dynamically typed. And so you can just try to access the weight field of X, and in this case it will work. C++ is interesting. In C++, you cannot check if something is compatible with some type. In C++, first you try to cast, and then you can check if the result is null. If you look at the example, this is exactly what I'm doing. I'm casting my X to Y, and then inside the if instruction, I check if Y is not null. This in C++, you can check this in this very short form. If parenthesis Y, this checks if Y is not null. It's interesting how can you cast in C++. There are two ways of casting, and the difference between those two has something to do with virtual methods. If the parent class has no virtual methods, you have to use the static cast function. Otherwise, you have to use the dynamic cast function. So you can sense here that those two cases are very different. How to say, they require different techniques in the background. Anyway, I just wanted to mention this to you because it's kind of interesting how other languages deal with cast and type compatibility. Some languages deal with them in a very ugly way, such as C++. Other languages deal with them in a quite nice and normal way, very similar to C#. I ran out of time, sorry. Is there any question at the end?
No.
No, you are already got exhausted, sorry for this additional time. So anyway, next week we meet again. So see you then, guys. Have a nice week. Have a nice lectures and courses. Bye-bye. See you.
See you.
Bye bye. See you.